25 years ago, mechanical design using solid modeling became possible due to a technology called feature-based solid modeling. Feature-based modeling introduced a clever trick to make solid modeling viable on 1980s hardware. It decomposed the design into a list of features that acted as instructions to create the shape of the part. To change a feature, you needed to retrace your steps back to where it was first defined. For simple parts and assemblies, the process worked great. However, as computers became more powerful, the CAD models became more complex. Additional concepts were developed to link features together, such as constraints, parent-child relationships, and interfile dependencies. Eventually, data management tools were developed to let teams work concurrently. Although these systems were very powerful, they could only be operated by trained experts. Many of the engineers who could benefit most from working in 3D were forced to stay away. Competing CAD vendors had different ideas about how the features and relationships should work, so they created software packages that were incompatible with each other. CAD interoperability problems became significant challenges for CAD users, their coworkers, and their supply chain. Now fast forward 25 years. Computers are 100,000 times faster, and a new way of doing mechanical CAD has emerged: direct modeling. In direct modeling, it's all about geometry. There is no feature history and associated complexity to manage. To make edits, you just push or pull on the object. Constraints and parent-child relationships are no longer required, so it's much easier for anyone to create and edit solid models. Direct modeling can be used with models created in any CAD system, even feature-based systems, because the technology works with the raw geometry itself. In some cases, feature-based modeling is still required. For example, if you want to create customizable variants of an extremely complex assembly of parts with well-understood relationships and requirements. But for a growing number of cases, direct modeling is quicker and easier. Say a design engineer is doing a concept drawing. He's got to test a lot of ideas. Feature-based modeling would slow him down because he'd have to know what assemblies, parts, features, and relationships he's dealing with before he starts. Every time he gets a different idea, he'd have to start again or rework his feature model. With direct modeling, he could build each iteration directly from the last one, adding and removing from each design without any hassle. Maybe you have to integrate components from a number of different CAD systems. Direct modeling works with imported data on its own, so modifying foreign and legacy data isn't a problem. Or let's say you need to prepare parts for simulation or manufacturing. In the past, everyone involved needed to use the same CAD tools. In many cases, the designs needed to be remodeled even for simple edits. With direct modeling, simulation and manufacturing users can simply edit the actual CAD geometry as required. What if you need to make changes to a model during a customer meeting? Feature-based modeling could be problematic. One rebuild error and the meeting is over. With direct modeling, you can make changes more intuitively without risking embarrassing failures. Direct modeling tools, like SpaceClaim, are the way to go for many situations outside of traditional detailed design. So while feature-based modeling is powerful, it has proven too complex for many applications and users. As computers continue to become even more powerful, you can expect to see direct modeling attracting a wider range of users to create and edit CAD parts faster and more intuitively.